Hello and welcome to this episode of Physical Attraction. This is a bonus episode. Wasn't planning on releasing this until yesterday when this news came out, and now I've thrown it together over the course of an hour, so apologies for any mistakes that may be included herein. But it's just a very exciting development that I kind of wanted to talk about and speculate about, because it's going to be all over the news in a few hours, and I think you would probably expect me to write something about it. So sometimes when a big news story in the sciences is set to break, there's what we call an embargo. Certain journalists get informed ahead of time about what the news is. For example, something like the discovery of the Higgs boson had this, which allows them to write up their pieces in advance and release a full, comprehensive and detailed account of what the discovery is and what it means. This system is there for a reason. It's there to prevent rumours, incomplete information, or inaccurate stories from circulating and then having to be retracted, which is damaging for the overall representation and reputation of science. And, I think we can all think back to the cold fusion that we've talked about before, and announcements that get made and then have to be retracted, and the fact that no scientific evidence is certain until there's real solid proof there, that you can be completely sure that this isn't signal that's coming out by any other case, as it was in the case of cold fusion. But last night something leaked past the normal embargo, and it's a pretty exciting story. I feel like we could all do with some wonderful sciencey distractions and speculation from everything that's generally going on in the world. So I'm sort of throwing a little bit of caution to the winds, and I'm going to talk about it on the understanding that this is still early days for this news, and that it will require a lot more investigation before we can be totally confident of what's going on here. Nevertheless, here's the headline. Astronomers think that they may have found biosignatures, that is to say, evidence of microbial life, in the atmosphere of Venus. So let's unpack this. Essentially, one of the main tools that astrobiologists have for trying to determine the probability of life on other planets is using spectroscopy. You split the light from planets and their atmospheres into its constituent parts. You determine the composition of the atmospheres that way. Given that every molecule has its own unique footprint in terms of light emission and absorption, you can look for these signatures in the atmosphere itself to determine what the composition of that atmosphere is. And we're getting very good now, even for far-off exoplanets, let alone Venus, analysing and studying the compositions of their atmospheres. So one of the major fields in astrobiology then, the search for extraterrestrial life, is to use these spectroscopic techniques to probe the atmospheres of other planets, looking for signatures that might possibly be produced by life. For example, one such potential signature that people have talked about a lot is methane. We know that methane can be rapidly destroyed by photochemical processes in the atmospheres of planets, and we also know that it's produced heavily by lots of life forms on Earth and other microbes on Earth. If methane continually shows up in the atmosphere of a planet, where conventional chemistry would suggest that it's in equilibrium there should be very little, then it may be a potential sign of life. Now, there's an ongoing debate surrounding, for example, measurements of methane on Mars and what significance that they may or may not have, as well as how reliable the measurements are, of course. Similarly, you might look for planets with, say, a large, unexplained buildup of oxygen in the atmosphere, which could be evidence of photosynthesis, which is very similar to what we know happened on primordial Earth, where you start getting these photosynthesizing molecules of, photosynthesizing bacteria, I suppose, that start producing huge quantities of oxygen on Earth. The point here is that we're looking for a process that inorganic chemistry, the standard chemistry of non-living organisms, can't really explain by itself. So you might have some model of how the planet's atmosphere should work, given the temperature, the pressure, the solar radiation coming in, all that sort of thing. And if you're finding chemical reactions and chemistry that's going on in the planet's atmosphere that can't be explained by another source, that chemicals that can't be generated by themselves by methods that we know about, then you have a gap. And in that evidence, you potentially have evidence that there's some kind of other chemistry going on, which could potentially be the chemistry of life. So in this particular case, a group of researchers have discovered evidence of a chemical called phosphine in the atmosphere of Venus. Phosphine, chemical symbol pH3, is probably best known to the general public as that gas that Walter White created in the first episode of Breaking Bad to kill a couple of drug dealers. It's toxic stuff. Now, the reason that this particular detection is interesting is that we don't really know of too many different ways that phosphine can be made. Here on Earth, some of it does naturally occur through the decay of organic matter. Now, it can also be created in the lab, for example by interacting phosphorus with potassium hydroxide, and we also know that under certain circumstances, when microorganisms are lacking in oxygen, it can be produced by microbes. Now, we don't specifically know the precise mechanism by which they produce the phosphine. It's considered likely that they probably absorb phosphate minerals, add some hydrogen, and expel phosphine. So there was a paper from 2019, which you can go up and find on the archive, this was released last year, called Phosphine as a Biosignature Gas in Exoplanet Atmospheres, which assessed the idea of using this gas as a potential sign of life. Now, I don't know how much attention this paper got when it first came out, and I'm hoping to talk to a few astrobiologists, including my good friend Rafael Alves Batista, at some point to try and talk to him about this and see whether this is considered a mainstream theory or a little bit wacky and out there. But at least in this paper, the researchers noted that this gas can be produced and has been detected in, for example, the atmospheres of stars and in the atmospheres of gas giant planets like Saturn and Jupiter. Essentially, these planets have high enough temperatures in some locations that the production of phosphine is thermodynamically favoured, i.e. it will happen by natural chemical reactions, and then it migrates from the sort of lower parts of the atmosphere to the top of the atmosphere in these planets through convection. And there, we've detected it and studied it for many years with our telescopes. But there aren't too many natural processes by which we would expect this gas to be made on a planet like Venus, which is likely too cold in most regions for its productions to be thermodynamically favoured. The point here is that the level of phosphine that you actually need to be detectable in an atmosphere has to be pretty high, parts per million rather than trace levels of parts per billion. This makes it difficult to explain by other mechanisms, such as volcanoes, lightning strikes that temporarily produce unusual conditions where it could be created, or delivery to the planet by other mechanisms from other regions, such as, say, meteorites or something. Those processes would all produce phosphine in far too small an amount to be detected from Earth, according to the authors of the paper. For that reason, they consider the presence of a significant amount of phosphine to be a strong indicator of one of two things. Either there's some new way of making phosphine that we don't know about, or possibly there are anoxic life forms, probably microbial life. So as I write this and read it out, this study hasn't yet been published, so we're going to sort of dig into it a bit more later on, so I am being a little bit preliminary here, but the results of it have been partially leaked over the internet and people are discussing this. So we're in a speculative mode, but as you can tell, I'm kind of quite keen to speculate on it. And if it turns out not to be true, then you just have a fun episode of me being overexcited over nothing, and you can all laugh at me later on. But the results of this new study, they suggest that they have found phosphine in rather large quantities in the atmosphere of Venus. This has been discovered by scientists from MIT, Cardiff and Manchester universities using the James Clerk Maxwell telescope and the Atacama Large Millimeter Array. Now, another indicator that is tantalising here is they think they found this phosphine in a region of Venus's atmosphere that has often been speculated as being a habitable region, where the temperatures and pressures aren't too awful in the sort of upper atmosphere here. I mean, the surface of Venus is basically just a death zone that would likely sterilise most forms of life that we can imagine. So the only place that we think life could really probably persist, or is most likely to persist, would be in this upper atmosphere. One of the study's authors is quoted as saying, quote, "Astronomers will think of all the ways to justify phosphine without life, and I welcome that. Please do, because we are at the end of our possibilities to show abiotic processes that can make phosphine." End quote. So what to make of this? I think before we get too excited, we should remember that the process of doing good science requires a lot of things before we can definitively say that a discovery has been made. I mean, for a start, you need your measurement to be really bloody good, and you need to make sure that you haven't made any mistakes in detecting it. Now, we know that one of the authors behind this paper, which says that phosphine is a good biosignature, is also one of the people who has detected it now. So they came up with the idea of looking for it last year, and in just a year's time, they've actually managed to find some on Venus. But that means, I think, that it may be that people haven't looked enough into phosphine, the chemistry of phosphine, and ways that it can be produced to be 1,000% sure that this would be a signature of life. I'm reminded of, for example, the experiment that thought it had discovered faster than light neutrinos. What they did was not actually to announce that they had discovered something that broke the light speed limit, although it was reported like that, but they instead invited other scientists into exploring this unusual result to see if they could explain it by other, more conventional means. Eventually, it was explained by much more boring means of experimental error, and special relativity survived as a theory, which we all sort of expected it to do. The point being here that before your work is thoroughly reviewed, checked, and you have several lines of evidence for your claim, it's too early to jump to any particularly radical conclusions. But that's not going to stop me from speculating about it. So what are the options? Well, perhaps the measurement is incorrect or the signal-to-noise ratio is off. Without really diving into the data, which we can't do yet, we can't say too much about that. I think that's probably the least likely explanation, because this thing has passed peer review and is due to be published. But you don't know. There's mistakes that show up in the peer-reviewed literature fairly often. One thing is for sure, if that is what's going on, we'll find out pretty quickly that that's an error, because people are going to come down on this like a ton of bricks. Everyone's going to be studying phosphine and the chemicals, if this makes a big splash, this announcement. And people will be studying the data from the telescopes and trying to detect phosphine with other detectors if possible. Another more likely explanation might be that there might be some new phenomenon in the atmosphere of Venus or other rocky planets that could produce phosphine. Now, it is a relatively simple molecule. It's pH 3. This isn't like finding some big chain of an amino acid or some huge strand of DNA or something where you think, okay, well, there's no way that that's being produced except by life. This is a fairly simple molecule which can be produced by many different chemical reactions. The authors claim that they don't know of any abiotic pathway, i.e. a pathway without life, that could produce this much phosphine. The mechanisms they considered could only produce around 1/10,000th of the phosphine that they detected. Although again, these calculations are also obviously going to be subject to a lot of scrutiny now, and who knows that they considered all of the mechanisms for producing phosphine. So for me, if this turns out not to be life, that would be my prior indication. That's probably the most likely thing that would rule it out as being life. Now, on that, of course, I'm not really qualified to comment. I don't know anything about phosphine or the chemistry thereof. But of course, it's also possible there's plenty of things we don't know about Venus, and maybe there is some new mechanism that we've discovered that could produce this kind of false alarm, in which case the initial hypothesis that phosphine is a great biosignature could be wrong. The scientists themselves say that either we've discovered life or our understanding of rocky planets is severely lacking. I have to admit that I'm nowhere near qualified enough to tell you which of these two options is more likely. It wouldn't stun me, of course, if people did come up with different mechanisms for producing phosphine in these large quantities, which actually don't end up requiring life. Certainly, you need some pretty hefty additional confirmation to be absolutely sure that this is proof that microbial life exists in Venus's atmosphere. The scientists do hope to do this going forward. The first thing to do will be to study the signal in more detail to see if there are changes over the day-night cycle, seasonal variations in the production of phosphine, which again might possibly indicate that there's something biological going on. It would also make an extremely strong case for us to launch more probes at Venus to detect the source of this signal and see if we can possibly get more evidence about what's really going on there. And I think that if this is not discredited fairly quickly, we're going to see some sort of additional probing of Venus, which will be an exciting prospect for everyone. If we find life, we may well find it with a probe, I don't know. Now, this discovery itself is a bit of a surprise, but scientists have speculated for a long time that microbial life might exist on Venus. People have thought that there are these unusual dark patches that absorb UV light. They may think that that's an evidence of life. These patches are composed of unknown particles that are about the size of Earth's bacteria. Carl Sagan suggested that life may be possible in Venus's atmosphere, but this life would be quite different to anything that appears on Earth. I mean, Venus is a very, very strange planet for anything that exists on Earth to really inhabit. It's got clouds made of acid and things like this. So it's going to be different to what we know of on Earth. And of course, there's no oxygen, so it would be anoxic life, and there's not water either. The liquid medium that would be sustaining this life wouldn't be water either, so it would be quite different. The scientists think that Venus used to be much more habitable billions of years ago, and even had oceans before a runaway greenhouse effect took hold. So, Venus had these oceans, and much like the oceans on Earth, they could potentially, if enough heating happened, evaporate. And as they evaporate, their gaseous form goes into the atmosphere, and of course it then absorbs infrared radiation from the surface and further heats up the planet. So you get this feedback loop that at some point on Venus, we think, has just accelerated the planet away from being a bit more habitable towards the sort of hellscape that it is at the moment. I should say, by the way, in case anyone's thinking about climate change here, that as far as our best understanding of climate change is at the moment, we know that the heating of the Earth evaporates the oceans to an extent and evaporates water from the surface, and it does increase the amount of water vapour that the atmosphere can hold. So there is a feedback whereby the heating of the Earth from greenhouse gases it's enhanced by the fact that water is evaporating from the surface. Now, we don't think that anything we are likely to do in the next 100 years could possibly trigger this into a runaway feedback loop. This was something that was considered possible in the very early days of studying climate change. I think it's much, much less considered to be a possibility now, because you'd need to do some quite severe heating. Even with all the fossil fuels we're burning, it seems unlikely. So, people have talked about Venus as an analogue for what might happen on Earth. I don't really buy it. I think you need a lot more evidence before you could say that. But of course, the mechanism of the greenhouse effect is just physics. We know that works on every planet because physics works everywhere. So anyway, when it comes to this history of Venus, we had a Venus that was quite hospitable and then underwent this runaway greenhouse effect, and life would have had to adapt somehow. And it may be that the only place it could survive would be in this narrow envelope of the atmosphere. I mean, we've talked, if you think back to the Teotwalki episode we did many, many years ago on the threat of danger from outer space. Life is a remarkably persistent thing, Even if we had horrifying events happen on Earth, like a global thermonuclear war, or gamma ray bursts, or supernovae, or something that roasted the Earth, there would still be life in deep sea vents. Life would persist through pretty much anything you could throw at the Earth. Even potentially the Earth being ejected from the solar system and going out into space. It's been calculated that some life somewhere would sort of continue to exist. Once it's established a foothold, it's quite hard to get rid of. So maybe Venus long ago, if this is all true, maybe Venus was teeming with life, and this is sort of the last vestige of evidence that it was, that life did form back when it was habitable. It's the sort of last refuge for any sort of Venusian life form that might exist would be in this particular region of the atmosphere. So that would be your hypothesis for how life get there. So what to make of this potential discovery? Well, of course, we need to take this with a great deal of scientific reticence, I mean, life in the Venusian atmosphere is a big claim, and it's still quite possible that when we've actually discovered it's just some interesting chemical or physical process that we weren't aware could happen on Venus that's allowed phosphine to build up. So before we start welcoming our new microbial overlords yet, we're due a little bit of caution here, and you'll want to see all the questions that come up at this presser to determine this in advance. On the other hand, it's a very tantalising prospect, and we all like to think about aliens, so given it's been such an awful year, let's allow ourselves now to speculate wildly about what this could mean. I've always been convinced that we're not alone in the universe. For me, this comes down to some very simple maths. You have two numbers. One, the truly vast number of potentially habitable planets in the universe, and two, the tiny probability of life developing on a planet while it's habitable. The idea, to me, that these numbers exactly cancel out when you multiply them to give you 1, the idea that we would be the only planet that has ever formed life in the universe, seems to me to be hopelessly naive and quite bizarre. Why would that be the case? Justifying it as being 1 is a remarkable coincidence. For example, a paper by Frank and Sullivan back in 2016 tried to estimate how unlikely technological civilizations would have to be, if you have a habitable planet, for us to be the only one that had ever developed in the universe. Now, they settled upon the idea that the lower bound would be around 1 in 10 to the 24, i.e. if you have a habitable planet, then you have to have odds of less than 1 in a trillion for technological civilization to develop on it. And only then would we be the only one that's ever developed. And getting a number that small seems quite unlikely to me. I mean, what's your evidence for that number? Now, of course, there's quite a big probability density, of course, that there are no other technological civilizations within our galaxy, and therefore it would be very difficult to communicate with them in other galaxies, but that there might be some in other galaxies in the universe. That may well be the most likely outcome that is most consistent with my expectations and our observations to date. We know that life can form under certain circumstances because we exist. We know that the circumstances that produced us have likely been reproduced countless times across the universe at different points in history. So any idea that we're all there is, frankly, would strike me as evidence of some kind of divine intervention. That's one perspective, and it's justified by the law of large numbers. Heck, forming life could be rare enough that it's only happened once in our galaxy, and yet there would still be potentially billions of other galaxies where life could have formed or could form. Essentially, the only upper bound that this belief sets, somewhere other than Earth that there is life, is that the formation of life is not next to impossible, but simply very, very unlikely. Maybe it takes 1 billion habitable planets, 1 billion years of random chemical reactions before you have that rare coincidence that allows life to form, but you could still argue that there should be life elsewhere in the universe. When you only have one data point, one instance when something happened, you can only really say that it's not impossible, Life on Venus, if detected, changes the whole ballgame there. If, as the scientist suggests, life formed many billions of years ago when the planet was habitable, and now exists only as vestiges in that atmosphere, with the surface totally inhospitable, then this gives us the thing that we've always hoped for in astrobiology: another data point. What's more, we'd be saying that of the planets in our solar system, life has formed on at least 2 of them at one point. If you want to talk about Bayesian reasoning, where new information updates your prior beliefs on a subject, holy hell, does this have to update your prior belief on how likely life is to form given the habitable planet? If life has formed separately on 2 planets within our solar system, that would surely mean that the probability of forming life on a habitable planet is pretty damn high. Either that or the old idea of panspermia, that life forms throughout the solar system and came from a single source, and that we were sort of all seeded from one source outside our solar system, maybe by a shower of meteorites that contain life or something like that. Well, I actually think that would seem to me to be more likely if we found life on Venus as well. Then, of course, you only need to explain a single origin of life in our galaxy or universe again, from whatever region of space it came to us from. Now, of course, saying the sentence, "the alien life on Venus may simply be our distant cousins," is too irresistible an opportunity to pass up. But if we did conclude that life managed to form separately on 2 planets in our solar system, given the sheer number of planets that there are in the habitable zone, and likely to have been habitable at one point throughout the universe, then you would expect the universe to be simply teeming with life. It's always been tantalising to note that, as far as we can tell with our one existing data point, life formed on Earth very shortly after Earth first became habitable, where the kind of conditions that life might form on Earth took hold. So, first you have the conditions for life to form, and it forms almost immediately. Well, I say almost immediately. It doesn't take billions of years, and we know that there were billions of years between now and when life first formed on Earth, so, almost immediately. Could be millions of years, but that's peanuts to space. If it's a low probability event, then you might have to expect to wait quite a while for it to happen, but it seems to have begun pretty quickly after the Earth first formed. Again, if we find evidence that life formed on Venus too when it was habitable, then that also totally flips the script by adding one more data point. Suddenly, you have to argue that life must have quite a high probability to form on habitable planets. And then the so-called Fermi paradox comes back to haunt us again. Where the hell is everybody? I'll remind everyone of the Drake equation. Okay, it's not really an equation, it's more a way of thinking about the factors that determine life in the universe. But we've got the rate of star formation, the fraction of stars that have planets, the mean number of planets that could support life per star with planets, the fraction of life-supporting planets that develop life, the fraction of planets with life where life becomes intelligent, the fraction of intelligent civilizations that develop communication, and the length of time that civilizations can communicate. Nowadays we have pretty decent constraints and bounds on the astrophysical side here. We know that stars form quite often, we know that there are plenty of exoplanets, we think that most stars probably have planets around them, planets are very common in the universe. We're finding more and more evidence for planets that seem like they could support life, or one day could, or one day did. They may well be abundant even within our own galaxy. Again, as I say, if this Venus discovery turns out to be independently developed life, then we suddenly have quite another high upper bound to set here. It would appear then that the fraction of life-supporting planets that develop life must be pretty high. Otherwise, it would be a hell of a coincidence for it to happen twice in our solar system. At that point, I think we would actually find it difficult to explain why we haven't seen evidence for other technological civilizations within our galaxy. We would have to assume that the great filter which reduces that number must lie somewhere else. Maybe developing intelligence is very difficult. After all, we have no evidence that life on Venus, if it exists, was ever actually intelligent. It could have only ever got to the microbe stage for all we know. Perhaps intelligent civilizations just don't want to talk with us. We could be the trash of the universe that no one could be bothered to speak to until we become more civilized. Or of course you have to consider how difficult communication actually is across such long distances, and perhaps it occurs in a different way or is much less common than we think. Or, alien civilizations from hundreds or thousands of light years away wouldn't bother to send signals to any planet that looks vaguely like it might be habitable without the knowledge that we're there. Or perhaps chillingly, as Fermi himself was worried about, it's very rare for technological civilizations to survive for that long. Do technological civilizations inevitably discover some technology that wipes them out? Is that barrier between being able to make things like nuclear weapons, nanotech, AI, whatever it may be, and actually colonising the rest of the galaxy, is that barrier much too high for the average civilization to vault? If so, what does that mean for our own future? Can we get out of that trap? And here we're really into the fun zone, going way into some crazy speculation, back into our series on existential risks, speculating about the end of the world, and all of the things I'd happily do for hours if you let me get carried away on the subject. So let's get back down to Earth, which we now discover there's a tantalising possibility, albeit only a possibility at this stage, is one of several planets in our solar system to harbour some form of life. All we have at this stage, realistically, is a clue, a suggestion that something unusual and unexplained is going on up there on Venus. We've all seen by now plenty of these exciting scientific stories, and we know that quite often there is a more reasonable and boring explanation for what is going on, even though initially the findings can seem remarkable. So I want to pour a little cold water on the excitement, given that it's still very, very early days with this story. We need a hell of a lot of extra research to be done to confirm such a huge revelation without any doubt. But at the same time, I really don't want to pour that much cold water on it. At the very least, it feels like 2020, which has been a terrible year for most of us, and particularly bad for me, I have to say. I feel like 2020 owes us aliens at this point. And so, if it were to be true, the philosophical implications of this are really mind-blowing. Cosmology and astronomy has been a relentless sequence of events that made us realise we are not the centre of everything, we are not as special as we think we are. First, we realised that we're not the centre of the solar system. Then we discovered that the pinpricks of light in the sky were other suns like our sun. Then that the smudges of nebulae in the sky that we thought were maybe clouds of gas and dust, it was discovered that many of these were whole galaxies by early astronomers, just like our own Milky Way. Suddenly the nature of the universe expanded massively. Every discovery has made us realise how small we are, and how vast, unknown, complex and fascinating the rest of the universe is. Every time we thought we were in some way special or unique, we turned out to be wrong, shaken out of our solipsism by observations amongst the stars. Would it really be such a shock for us to realise that we're not the only living beings in the universe? Not the only intelligent life? Not even the only life in our own solar system? If this turns out to be true, and we, poor, foolish, misguided species, somehow manage to stumble and stagger through the minefield of the 21st century and on into the future, this would be a pivotal discovery in our history. The moment we realised, the moment we had first signs that we were not alone as living beings in the universe. And if you can't let yourself get a little bit excited about that prospect, even if it is only a prospect, even if there's a long way to go to actually prove it, what can you get excited about? Thank you for listening to this rather speculative episode of Physical Attraction, this very thermonuclear take, so to speak. Maybe I'll do another episode in a few days saying, false alarm everybody, sorry about that. But in that case, at least you will get to laugh at this snapshot of history. You can find us, of course, on the web at physicspodcast.com. If you have any comments, questions, concerns, any speculations on the origins of life, extraterrestrial or otherwise, please get in touch via the contact form there. And all the other stuff, Twitter, Patreon, PayPal, etc. I've released a few more episodes than I expected to this week, so there might not be one on Thursday, depending on how things go. But I'm sure that this will tide us all over with speculation for quite a while yet. And I will, of course, keep you posted on this story and on everything else we like to keep track of in future episodes. Until next time, then, please take care.